Hello students, welcome again to the new segment. In this segment, we will be looking at some more information regarding the k-nearest neighbor algorithm. So the first thing that we want to emphasize is the scaling issue. So there is a variant of the fitcknn function which allows you to standardize your variables. That is, all the variables will be scaled between certain range, so they will have the same range, right? So it will take out those issues that one variable has a very large scale and the other one has a very small scale. Of course, it will affect the performance of nearest neighbor algorithm a lot. So let's see how we can do that. So for that, let's read certain data set, which in this case is the RS Setosa data set. And we know that it is located in the C directory under the name 1. So this will read our data set. Now once our data set has been read, we want to use a particular variant of this fitcknn algorithm. And of course it needs two pieces of information. One is the table data structure, which contains our data set, and the other one is the variable name, which it will use as a class label. So now in this case, we want to mention that the number of neighbors are 5. And then this option that we were talking about, the standardize. So when we set this to 1, it means that we standardize all the variables. And by default, it will be set to 0. So it has two possible values, 0 or 1. 1 means that it is on, and this property is on. So all the variables are going to be scaled. And if it is not selected, by default, it is going to be a 0. So when we press enter, it is going to learn a model where all the variables are going to be standardized. So that's very useful option, and I would strongly encourage you to use this. The second point that I want to mention here is that whenever you are trying to compare different models, right? So for instance, we have a KNN with k equals to 5 model and another model, another KNN model with k equals to 7. Right. So instead of working with the same variable, that is MDL in this case is our model, we can make copies of it, and then it will correspond to that different values, right? That different parameter setting. For instance, this MDL N1 is now a copy of this MDL, and we can update the properties of this MDL1. For instance, we can change now its number of neighbors, and we call the number of neighbors in this case is, let's say, 7. So now if we change this property of the original model, so then remember that it is going to be updated. So you lost the original model with number of neighbors equals to 5. So whenever you try to compare different models with different parameter settings, so it's always very advisable to make a copy of that. Right. And one thing more is that if you are working with larger data sets, so then in that case, learning a model, every time learning a new model would take significant amount of time and resources as well. So in that case, just make a copy and then update the corresponding parameters.